Hello everyone. So today we are going to understand what is fixed window counter rate limiting algorithm. So this algorithm divides the time into fixed windows and counts the request in each window. Now let's understand how does this work. Let's say a request arrives to our application server. So first what this algorithm does is it determines the fixed current window. So how this determination is happening is like, let's say a request arrived at some previous timestamp and the new request is coming at this timestamp, let's say t dash. So it will identify t dash minus the previous timestamp, which is t. And in this way, it will identify the fixed current window. We'll see this, how this is identified in the implementation part, but this is how it will identify. Then it will check that whether it is a new window. Now, what does this mean? So let's say for this algorithm also will have two parameters. One will be the window size which we will define, and the maximum request which will be served in that particular window size, right? So after determining this current window, it will see that whether this is beyond my window. Let's say we have defined a window of 1 second, and let's say it was beyond that time, so it was more than 1 second, so which means it's a new window. So once it determines that it is a new window, it needs to reset all its parameter. When I mean resetting, so resetting is nothing but whatever the current start was there for that particular user. Like here also we are rate limiting per user only, as we have been doing in all of the algorithms previously explained as well. So here we'll be rate limiting for per user request. So first it will reset the maximum request quota for that user when the resetting is happening. And it will also make the current start for that user now for this new request as the current time. So let's say it was not a new window. So it was within that window of 1 second frame, which we have defined. So what it will do is it will check the limit. So as I mentioned that we are also maintaining one more parameter, which is the max request. So it will check that whether this user has exceeded its quota of like hitting a request to our application server. So let's say it has, then it will reject that request completely. And if it has not, then it will go to that particular user information which we are holding to track how many requests that user has made and when the last request was made. We'll go there and increment the count of that request, and it will process that request. So this is how this algorithm works. Now let's understand this using an example for better clarity. Okay, let's understand this using an example. As I mentioned that here also we'll be maintaining two parameters. One is the maximum window size and one is the maximum request per window. So here the maximum window size is 1 second. In 1 second, we'll try to fulfill three max requests. So that is identify the maximum request count. Now let's understand using this timeline diagram. So let's say time t equals to 0. We got three requests simultaneously from that particular user. All of these three requests would be fulfilled. Now at time t is equals to 1.2 seconds. So now we have crossed 1 second window, which is at t equals to, if we would have got at t equals to 1 second any more request here, then it would have got rejected. But now we are receiving the new request at timestamp t is equals to 1.2 second. Now, like any of the requests which is coming in, uh, like three requests which came from this user got satisfied, but we got additional fourth request which would ideally get rejected because of this constraint. Now let's say at time t equals to 2.3 second, we got one more request. Now as we have crossed 1 second window from the previous time when the request was hit to our application server, we'll be able to fulfill this request and hence we'll process this. Now let's say again after 1 second, we got five more requests from the same user. Three of them would get fulfilled and two of them would get rejected because of the same constraint. Now let's deep dive into the implementation of the same. So here I've created a class fixed window rate limiter. We are maintaining the two parameters, which is the window size in seconds and the maximum request per window. And we'll also hold a map for per user request information, which will have a string as a user ID, and the request info will hold how many requests that user has made and what was the start at which the user started making requests to our application server, so that the current window start will hold for that particular user. Now, this is the constructor which will initialize with whatever the parameters which we want to initialize with for the maximum window size and the max request per window before starting this algorithm. Now, what does this function do? Allow request. This basically checks whether the request should be allowed for that particular user or not. So main logic lies here. Now, first we'll identify the current time when this request is coming to our application servers. Then we'll see that whether this user is making the request for the first time or it has already made in past. So let's say if it was the first time, then we'll set the request info for that particular user, like with what is the maximum request per window that user can make and the window start. So right now we are making this request per window initialized to zero. Like whenever the new user is coming to our application server with a request, it's like it can make three requests. So we'll set that maximum request the user can make initially for the first time as zero. So that is what I've done here in request info class. So I've just created a class to hold this information. So I have set this max request to zero and the window start is the current time at which the request is made. So, like when this user makes the request, we'll set initially with that current time, right? Now, what we'll do is, let's say that was the instance when the request was made for the first time, right? So, let's say a request was not made for the first time, then we will fetch. In both the cases, we'll fetch the information, but when it was made for the first time, we'll set its parameter of this two max request and window start for that particular user with this all information, which is the current time and the zero. Now let's say the request which was made, like it was not made for the first time, and let's say there were some requests made by that user previously as well. So at that particular moment, this max request count would be some value. Let's say it was made twice, so it would be set to some value like two or one or how many times it has been, right? So what we'll do is we'll fetch that information for that particular user and we will check that whether this request when it is coming to our application server at this current time and the user request info when it made for the first time, which was the windows start, right? So windows start will be initialized when it was made for the first time, right? So when if the difference of this is less than, I mean it is not exceeding our window size in seconds, then we are good. Like we can allow the request and it won't go in this if condition and it will try to check this scenario, right? And let's say it was like we have crossed 1 second window. If this like if just this check executes, it will go and reset. So what does this reset do is for that particular user now what this algorithm is doing is like whenever we cross that 1 second window at the start of the new window, we make sure that we allow that user to make uh, that maximum three requests, right? So it resets. Resetting is nothing but what it does is it sets the max request to zero again, and the window start becomes the current time, right? At which this new like new request is coming. So that resetting is nothing but that resetting with the previous configuration when the request was made for the first time. The same configuration will reset it to. And let's say we have not exhausted that window size of 1 second. We'll try and see that whether that user has not exhausted its limit of making a request or application server. So we'll get the max request for that user and we'll check that whether it is within or it is less than the maximum request which we have defined. If it is, then we'll increment it for that particular user and we'll allow that request. If it is not, we'll deny. Simple enough, right? And so this is how this implementation is looking. So before simulating this, let's understand few of the instances where we have make sure that this implementation is thread safe. So first thing is like we have made sure that whenever the user information is getting stored, we make sure that it is not overridden or it is not uh, like whenever we have multi-threaded environment, when this code is simulated in that environment, we don't want that we run into race conditions where whenever this line is getting hit, and let's say that user's request for the first was for the first time. Let's say two of the threads simultaneously are trying to execute this, and due to some of the context switches, one of the thread was paused for some time And let's say a request info bucket was created, not bucket, but basically this information object was getting hold for this map. And let's say another thread came in after some time, and let's say even the previous when the previous thread executed, this request got satisfied, and let's say we had some value of the max request count incremented. But let's say the previous thread, which was also trying to execute this, saw that it is not created and it goes ahead creating. So once it goes ahead creating, it will reset everything. So we might run into a situation where we will be satisfying more number of requests rather than satisfying whatever the request we have identified, we have defined in the max request per window. To understand this more deeply, I've covered this in one of my previous videos where I've explained the concurrency problems which we face, and I'll drop a link in the description. If you want to go and check it out, you can check it out there. So concurrent hash map in Java will make sure that we don't run into the race conditions of creating multiple request info for a particular user. Now let's say I have also we want to make sure that whenever the requests are getting satisfied in the multi-threaded environment, we don't want that we have just, let's say, one request to be satisfied, and if we are not making this thread safe, we might run into a situation where we are satisfying more than one request. So what does this mean? Let's say there was one thread which came in, was trying to satisfy this condition. It went through, it has left with one request, and it made the count of that request as 3. So next time when that same threads come in, like if the user is hitting the application server with the more request, right? Like 4 requests and 3 got satisfied. Now fourth request is picked up by some other thread, assume, right? It also comes in here. And let's say this operation of checking this user information should be allowed or not, incrementing and decrementing of all this information is not made atomic. So what might result here is the other thread also would come in. It would read the older count of the request, which was 2, and it will also try to satisfy. So technically, we are allowing user to make 4 requests, which is violating our condition of this algorithm itself. Like we want just 3 requests to be made per window, right? So here, by using the synchronized keyword, what it will make sure is resetting of the window and the incrementing the request count is atomic. So whenever any of the thread is executing this part, it will make sure that any other thread which is coming in for this request satisfaction will get blocked for that particular user, right? And also we have atomic integer in Java, which makes sure that increment and decrement of an operation whenever it is happening is like make sure that concurrence it's handling concurrency and the consistent value is maintained, and in thread safe environment in thread multi-threaded environment this won't result in the race conditions. So you can read that in the documentations of the Javas as well, you'll get to know. So that is what I've used for the max requests for that particular user. And yes, so this was all about how this code is also thread safe when executed in the multi-threaded environment. Now let's understand its simulation and check in main how it works. So here I have made the window size in second is 1 and the maximum request per window is 3. And this is simple date formatting to have a better view. And so first thing is like as I explained in the example as well, right? So let me show you again. So here we were having 3 requests which was coming in, right? So at time whenever I'm starting in my code, I'm trying to hit my application server with 4 requests. So technically 1 request should get rejected. So out of these 4 requests, 1 request should get rejected and 3 should get satisfied. Then I have kept a delay of 1 second. And after 1 second, I'm again hitting my application server with uh, 3 more requests, right? So after this, I mean, this 3 requests should get satisfied. And even after the delay of again 1 second, I am trying to hit my application server with 3 more requests. This all the 3 requests should get satisfied. Now let's understand this and see in the terminal how it looks like. Okay, so when we made the four requests simultaneously, one got denied and three of them got satisfied. So this is the time at which the request is getting made. Okay, and after a delay of 1 second, three more requests came in which got satisfied. And after a delay of 1 more second, three more requests came in and which got satisfied. So I think this implementation makes sense to you. Now let's deep dive into the pros and cons of this algorithm. Okay, what is the pro? So basically, this is very easy to implement and understand, and it also provides a clear and easy to understand rate limits for each time window. And what is the con of this algorithm? It does not handle most of requests at the boundaries of the window well. It can allow twice the rate of the request at the edges of the window. What does this mean? This is the most interesting part to understand. So let's say a user is making request to our application server at time t is equals to 1.9 second. Three requests are simultaneously hitting to our application server. So at the start from 1 second to 2 second, at the edge of the window, we got three requests, which will technically get satisfied. Now at the time of 2 second, this window resets, right? Now at the time of reset, we will allow for the next window any request, like three requests would be allowed for that user. Now let's say time t is equals to 2.1 second, three more requests simultaneously is coming from that user. All of this will be allowed. What is this happening? So technically, if you see in the time interval of zero point 0.2 second, so if you subtract 2.1 minus 1.9, 0.2 second, we are allowing six requests. Technically, in a 1 second frame, we are allowed only three requests to be made by that user. But here we are allowing six requests, which violates the rate which we have defined, which is three requests per second. So this is like it does not handle the burst at the boundaries well. So if this is the scenario, our application server might run into a way like user can maliciously try to hit our application server at the edges of the window and make sure that more number of requests within that time frame are getting satisfied within time frame, meaning at the 2.1 second and 1.9 second, like we have defined 1 second three requests, but we are satisfying more number of requests in less time. So this can allow like twice the rate of the request at the edges of the window. So yeah, this was about fixed window counter algorithm, rate limiting algorithm. I hope you like the content. If you like the content, do like, share, and subscribe. And see you soon in some other video with some other interesting content. Till then, bye bye, take care, and have a nice day.